Hi everyone, welcome to Naresh Technologies. This is Srinivas. In the last session we discussed the basic points of stack. So in this session we are going to discuss how to implement a stack using static arrays. So nothing but with the constant size, how can we perform all the stack operations like a creation, right, storing the information, removing the information, printing the information, all these things. Okay. So already we discussed in the stack abstract type, so many specifications they have given, right. All these specifications now we are implementing with logics using C language syntax. Okay. First, so first of all, creation of a stack, creation of stack. So stack creation is very easy, stack creation. So initially suppose we are declaring capacity, one variable capacity, any capacity you can give. So that is 5, that is 5. So in the main method, either locally you can declare or globally we can declare. Mostly, right, variables we are declaring globally only. The reason we are accessing the stack from different functions in the program. So this is a global variable capacity, and next one, so one more variable is a integer stack, integer stack, and what is the size? What is the size means, suppose I am giving the capacity, I am giving capacity. Sir, here doubt. In C language, whenever you declare a variable like this, it is impossible to pass another variable in the form of square brackets, right. In a size you cannot specify ordinary variable, impossible case. Sir, then when it is possible, when it is possible means instead of declaring ordinary variables, we have to declare a macro. So macro is nothing but a constant. So how can we define constants? Using preprocessor directives. So using preprocessor directives, how can we declare a constant means hash define capacity. Constant variables mostly we are using, we are representing with the help of capital letters only. Capacity 5, there is no space, there is no semicolon, there is no equals to symbol. This is identity and this is the value, right. And here, so now we need to write all our capital letters because C language is a case sensitive language. Capacity, capacity, right. Here, so hash define is a preprocessor directive, so which is used to create a constant, nothing but a macro. This is a macro name and this is the macro value, macro name and macro value, right. Only macros we can pass. Whenever we are declaring ordinary variables, we can pass macro. Why, sir? What is the reason? Here, right, in place of a capacity, the 5 will be substitute at the time of pre-processing phase. Pre-processing phase. Pre-processing phase means that is before compilation. Before compilation of application, C application, pre-processing phase will be present. Right, in a pre-processing phase, the value of this macro will be substituted here. Then by that time, right, at the time of execution, memory will be allocated to this stack. Okay. So this is how to declare a stack variable, right, with the help of a constant size. Constant is nothing but a, right, preprocessor macro. Preprocessor macro. Then how the memory will be allocated? Just we are writing in the form of a stack. We are writing in the form of stack, right. So what is the size? Size is a 5. size is a 5, right? 0, 1, 2, 3, 4. And remember two things. First one is a capacity, all are capital letters, sorry. Capacity is a 5, capacity is a 5, so index 0 to 4. And next, array variable always holds a base address. The base address, suppose 2046, 2048, 2050, 2052, 2054. So here it is, stack is holding the base address. The base address is a 2046, is pointing to the stack. And one more we discussed in the introduction of a stack, right? In the stack, so whatever the operation you want to perform, right, either insertion of elements if you want to push any element, deletion of elements if you want to pop any element, all the operations you should perform from the top of the stack. Sir, physically nothing but generally, so we can say that, so we are performing means what, we are inserting the elements from the top, we are deleting the elements from the top is okay. Physically we can show like this. Sir, programmatically how can you perform all these things? Very simple. You have to declare one more variable, integer, one more variable you have to declare. So what is that variable name? Top. Sir, what is the value? Initial value equals to -1. Initial value equals to -1. So here top equals to -1. So remember, variables capacity is a 5, top variable value is a -1. Sir, why sir -1? Because if it is a 0, it is pointing to the first location, index. As of now, top variable is not pointing to any index, so the value is a -1. So this is just a creation of a stack, simply declaration of an array with the name stack with a constant capacity. Constant capacity is once again preprocessor directive, it's a macro. This is creation. Okay. Next we will see how to insert elements into the stack, nothing but how to push the elements into the stack. How to insert the elements? See, for example, method is a push method. Push method, it is not returning anything to anyone, but what element you want to push, that it is taking as an argument. If you want to push an element into the stack, what element you want to push, that you have to pass. But remember, so whatever the element they are passing, that we cannot store directly into the stack. Reason, because here stack is a fixed size, right? It is a static memory allocation, and of course it is a dynamic memory allocation also. So first we have to check whether there is a chance of inserting an element into stack or not. If stack is a full, right, or so in dynamic memory allocation there is no memory, right, to store the next element into the stack, so that will fail, is a failed case. So first we are checking if a stack is full. Sir, how can we check sir stack is full? For that logic we are writing in another function. Sir, what is that function? Function is a is full function. Is full. Inside the if block we are calling one function is full function. So logic for is full function we'll see. So what it will do means, is full function return type is a integer. If stack is a full, it will return 1, right? If stack is not full, it will return 0. Okay, on success it returns a 1, on failure it returns a 0. So like that you have to write. Logic I will show you very clearly. Okay, so here how is full method will be. Method is a is full method, is full, return type is a integer. if a stack is full, the condition, full condition I will show you, right. If a stack is a full, it returns 1 if condition is a true, or else it will return false, it will return 0. The conditions will discuss, because according to operations, if I explain, you will get more clarity on this. As of now, what is the condition? Put aside. Now observe. So first of all, stack is not full, stack is empty only, stack is empty. So whenever you call is full, it returns a 0. So if block fails, else block execute. Else block. In the else block, what we have to write? In the else block, we are writing insertion logic. So what is that insertion? Element we are inserting, element. Where we have to insert? In the first location. Sir, how to insert? Elements insertion is possible with the help of top element only, but top is not pointing to 0. Actually, we have to insert element into 0th location, but the top is what? Is a -1. So first increase the top value. Here first what you have to perform? Top plus plus. Increase the top value. Observe here, a top value become 0. Top value become 0. Now it is pointing top. So now we are storing element. We are storing into which location? Into the 0th location of stack array, right. So here into stack of 0 is nothing but a top. Into the location. Sir, element is what? Suppose consider element is a 10. 10 will be inserted. 10 will be inserted. So next one. So clearly we are printing one message, printf element inserted or element pushed into the stack. Right, here it is. So percentage %d means what? Element. This message will print clearly on the screen so that end user can understand. Okay, so whatever the element I just want to insert, so that will be pushed successfully, pushed onto the stack successfully. So that is insertion of element, insertion. And next one, right, this is a first element insertion. Next they are calling this push method once again, second time they want to insert one more element, 20. So same story, again else block will execute, because is full condition fail, because the stack is still having some of the locations to insert the elements, chances are there. So here it is a top plus plus, so top value become 1, element will be stored into 20. Next I want to insert one more element, for example, right, 30, top value 2, element is a 30. Next top value 3, element is a 40. Top value 4, element is a 50. So now no chance of inserting the elements, no chance. So by this time, whenever they are trying to call push function once again, now is full method should return the value 1. What is the condition? Based on which condition? Very simple. So top value is a 4. Whenever top equals to capacity minus 1, top equals to capacity minus 1. Reason? Capacity is a 5, 5 minus 1 is a 4. Top value equals to 4. Whenever a top value reaches 4, so then automatically stack is full. Yes, now top is a 4. 4 equals to 4, condition true, then it will return 1. So by this time it is returning full. Then we are printing the message printf stack is full message we are passing clearly. Stack is full message. Okay, so this is the logic that how to insert the element into the stack, how to insert the element into the stack. So first, whenever we are inserting the element, first you have to pass that element. Directly we cannot insert. First we have to check whether the stack is full or not. Directly we cannot write the logic here. So we need to take the help of another function. So what is the function? Is full function. Is full function will return the stack is a full or not. If stack is full, it return 1. If stack is empty, nothing but some of the locations are there to insert the elements, it returns 0. That we are collecting. In the else block, here it is a top plus plus, just we are increasing the top value every time. After increasing the top value, element we are inserting into stack of top. Sir, why sir we are using top means? So this is the thing that we are performing all the operations into the stack with the help of top. Here also, to check whether the stack is a full or not, we are taking the help of top. This is representing we are performing all the stack operations with the help of top, from the top. So that's why, so mostly we have to concentrate on a top variable. Every logic you should write with the help of a top variable. Okay. So this is how to insert elements into the stack. So now we'll see how to pop the elements, nothing but how to delete the elements from the stack. So first we are writing stack with some elements. Suppose elements are 10, 20, 30, 40, 50. So we know that capacity is a 5 and top is pointing to 4. So initially top is pointing to 0, next 1, 2, 3, 4. Now top is pointing to 4. And next here it is a base address 2046, 2048, 2050, 2052, 2054. 2054. Here it is the base addresses, and the base address of a block will be stored into a variable stack. So that stack is pointing to that array variable. So we can call it as a stack. Okay. So these are the things already we discussed. Now how to pop the element from the stack. So method we are writing. Method name is a pop. So this method should return in integer. This method should return an integer. Here it is. So return type is integer and it is not taking anything. Sir, why sir? Why pop method is not taking any element means? So whenever you call the pop method, always it will delete the top element of the stack. We cannot delete a particular element from the stack, because always last in first out, what you inserted last, so that will come out first, simple thing. So that we have to pop. So first we are declaring one element ELE. Sir, can I pop the element directly? Impossible, right? Reason, first elements are present or not in the stack, we have to check. Suppose if a stack is empty, then we can't do anything. So if we have to call a method is empty, right? So what is empty method will do? Is empty method will return 1 if there is no element in the stack, right? If it returns a 0, that means a stack contains some of the elements. If there are no elements in the stack, it is returning 1. If elements are there in the stack, it returns 0. So for example, if elements are not present, then it returns 1 if one condition true and it will execute. But as of now, according to our stack, elements are there, right? Already elements are there, 5 elements are there, right? And here it is a top value is a 4. Top is pointing to this 4th location. So here we have to pop, nothing but we have to remove the top element only. So top element is a 50. Okay. So here else block execute, else block. Sir, can you write the logic for isEmpty function? Yes, parallelly I will explain isEmpty function also. isEmpty function, isEmpty, and here also condition, on some condition, if else we will write, if else. isEmpty method is returning 1 or 0. So 1 or 0, that is integer, just consider. Suppose if it is empty, if this condition is a true, it will return 1. If this condition is a false, it will return 0. Sir, what is this condition? We will see whenever it reaches. Okay. Now, as of now, so stack already having some elements. So whenever you call isEmpty method, else block executes, it will return 0. So 0 will be collected here. If 0 condition false, come to this else block, and here we need to delete the element. So stack of top element we have to collect. Stack of top element we are collecting into ELE element, and next after removing this one, top should pointing to the next location. Top should pointing to next location after deleting this element. So here, right after deleting this one, so top minus minus we have to do. Top minus minus, and finally we have to return top. We have to return top element. That's it. Either if block execute or else block execute. Here it is a return function, return statement will return the top element. Right. For example, if top element is not there, top element, right, element is not present, then if block will execute, it will return 0. Just consider. So nothing but element equals to 0 you can assign, or directly you can return 0 directly. Okay. So here it is a pop element, means always returns the top element. So second time we are calling, second time also elements are present. So we are deleting this one, 40 will return and top will come to here. Next 30 we return, top come to here. 20 we return, top here. 10 will return, top become -1, top value become -1. So whenever top value is equals to -1, so what is the meaning? No elements in the stack. See, that means whenever top equals to -1, in the beginning also, at the declaration of top value also, by that time top value is equals to -1, top value is equals to -1. So by that time, right, so it is returning, right, a value, isEmpty function returning the value 1, because isEmpty means yes, it is empty. So whenever you are calling isEmpty, if top is equals to -1, it is returning 1, 1 come to here. If 1 condition true, come inside, right, directly it is returning the 0. Sir, 0 where you are collecting? 0 we are collecting, right, in the calling method from where a pop method has called, there we collected. Suppose if it is returning the top value, there we are printing the top value. Suppose if it is printing 0, so there if the returned value is a 0, so there we are printing the message stack is empty message, or else the returned value we will print. So this is, right, deleting the element from the stack, nothing but pop the element from the stack. Two methods we are using, one is a pop method and next method we are using isEmpty method we are using, isEmpty. Okay. And the next method we will see So what is the peek method? So what is the peek method means, right? It will return the top element, but it will not remove the top element. Simple. Peek method. So what is a peek method means? It will return the top element, but the element will not be removed. For example, here on the stack, suppose elements are 10, 20, 30, 40 only present. So top is pointing to 3. Top is pointing to 3 because 4 elements are there. Capacity as usual 5 and stack is pointing to this one. Now, so peek method means, so as usual, first we are checking if stack is empty or not. So same story, if stack is empty, it will return 0. It will return 0. Return type is a integer. Is empty means what? Same function just now we discussed, right? If there are no elements in the stack, it will return 1, right? If already elements are there, it will return 0. If stack is empty, it will be 1. If one condition true, it will return 0. Nothing but peek method is not returning any element, because if return value 0, in the calling function we will write there are no elements in the stack to print, or else so directly it will return the top element, return stack of top. But remember one more thing here, in the last program, nothing but in the pop, after returning a stack of top, we are doing stop minus minus, nothing but it is pointing to the next location. So here no need to write this stop minus minus, because after returning the top element, peek element after returning still the control pointing to the same location, it is not pointing to the next location. Understand the difference between peek and pop. Peek means it will return the top element but not removes. Pop element means what? It will return the top element but removes. Sir, here it is one more thing that we are not getting is what? Sir, you are saying the data is deleting. Sir, where you are deleting the data? How the data will be deleted? And one more thing, in any programming language, you are deleting the information from the memory means you are just make the pointer which is not pointing to the location, that's it. Except that it is impossible to delete the data which is inside the memory location. Impossible case. There is no such type of function to delete the information which is inside a memory location. The people saying that deleting, there is no question of deleting. Only just a pointer which is not pointing to location. If you write a top minus minus means what? Top is start pointing to this location. Sir, then what about this location? It is there, still data will be there, that is working like a garbage value. Next time suppose if you are inserting one more element, then by that time the element will be overwrite. So that will be rewrite with another value. Only rewriting possibility is there. It is impossible to delete the memory location, or it is impossible to delete the data which is inside the memory location. Only you can replace that information, that is only possible. Okay, right. So here just we are not doing top minus minus. Here in a pop method, top minus minus operation. Peek method means what? It is returning stack, top of the stack, but it is still pointing to the same location only. Okay, so this is the peek method. Now the last method, last functionality of a stack abstract data type. So what is that? How to traverse the elements. Sir, what is traversing? How to print all the elements of the stack is nothing but a traversal. How to traverse all the elements of the stack. So function name we are writing void traverse, it is printing directly. Traversing means what? Just displaying the elements. Displaying. So first, as usual, we are checking if stack is empty or not. Same story. If stack is empty, directly we are printing a message, no elements in the stack. No elements in the stack. For example, stack is having some of the elements. For example, here it is a top value is a 3. Stack contains 4 elements. So then you have to traverse all the elements. Two options. Either you can traverse from 10 to 40 or 40 to 10. That is your interest. Simply using for loop. Printf stack elements are for loop. I value starts with 0 to I is less than or equals to top I plus plus and we are printing printf %d / n simply stack of I, because I value is iterating from 0 to up to top location. So top location is a 40. Okay. So here it is I value 0, right. So 0 is less than or equals to top value is what? 3. So 0 to 3, that we are collecting 10, 20, 30, 40, all the elements. Here just declare the variable I we are declaring there, or here also you can declare, no problem. Okay. So this is completely about all the operations of a stack. In the next session we will see how to implement practically. I will show you the program how to implement a stack, nothing but just all these logics. So we are writing into a single program, then you will understand, right, how to perform stack operations and how to combine all these functions into one place. Okay. So thank you for all. So thank you for watching. For more videos, please log into Naresh IT channel. Thank you.